So my name is Nadav Malin with a company called Building Green, and I'm a board member of the Rich Earth Institute. This panel is called From Individual Practice to Infrastructural Change. And it's really addressing, I think, one of the biggest, most challenging aspects of using urine diversion, nutrient reclamation, become the solution at the scale we need it to be, which is taking practices that are right now happening very much at the individual level based on the passion and commitment of individual actors and making them something that is easy for anyone to do.
I'm going to share some of my sort of ideas related to urine diversion, which is really centered on building scale urine diversion in commercial and institutional buildings. And I'm an academic researcher. I've been studying this topic for about 10 years. So in my opinion, the biggest obstacle to urine diversion is the logistics. My vision is to transform the urine that's collected in commercial and institutional buildings into valuable nitrogen products, phosphorus products, and water. How do we achieve radical change? My approach is that we can actually achieve radical change in incremental steps, from laboratory research to community scale collection like the Rich Earth Institute. And now there's researchers who've implemented in their buildings, like in Switzerland and Sweden, and now trying to scale up whole building, which is what we're doing at Arizona State University. Once we've realized this in full buildings, we can go to multiple buildings and citywide. So I don't think there's any shame in approaching this in an incremental manner. And I think that can allow us to get to the radical change we all want.
Hello from Vienna. We developed a technology to collect urine, quite elegant. This is a scheme where you see roughly how it works. So we really, from luxury to helping local craftsmen to adapt this technology, we really try to make our contribution to this topic.
My name is Will Tarpey. I'm an assistant professor in chemical engineering at Stanford. My lab, we work across scales, so from the molecular scale all the way up to the system scale, as Trevor mentioned too. So I think there are many challenges, but I think we're making progress on all of them. First, I think is economic viability. Part of this is that fertilizer prices are hard to beat. Depends where you are in the world, but making fertilizer from urine can be economically challenging. So I think this is related to a second challenge, which is how do we make high purity marketable products? And still thinking about cost, depending where you are in the world, there are sunk costs in existing infrastructure. So getting people to change from combined sewers for full wastewater to urine diversion can involve large behavior change. And finally, I think there's some challenges in prioritizing value propositions. Urine diversion has so many benefits, and within our community, I think it's easy to see. When I talk to people outside of our community, it can be a little hard to know which is the major benefit, or people want to know what are the top two benefits. One of the things I'm really passionate about that we've done at a few Rich Earth Summits is think about where we want urine diversion research, practice, and education to be kind of across the decades as we look at it. And also, what input do we need from other communities, whether that's fertilizer producers or disinfectant producers or business people, to really accelerate the adoption of these technologies and these practices. So.
I'm Laura Allen, and I work with Greywater Action. Urine reuse and separation is kind of one tool in the toolbox, so presenting it to interested people who want to shift the way they manage water in their home and their resources, having it be like one option for them and trying to find when it's a good option and what's going to be the best for their situation. And I see the same obstacles really for all of these sustainable technologies. Education, people don't always know the options. They don't understand what they can do, the true risks versus the perceived risk. And many people think that these kind of green technologies in the home have to be really expensive or really complicated. And they don't. There's really simple things we can do at all scales. And then we have the technological and logistical challenges. And then the last is the regulatory side. I have more experience with Greywater through popularizing these simple, affordable systems that people could do in their own homes. That really helped push a larger change, which was our state code. When the people involved have really tried it out in their own homes and know more or less what it entails, it's easier to say yes to these bigger projects.
Building off of what Trevor said about radical change, this is what we face whenever we started talking about even waterless urinals or composting toilets. And I think that often this is the stop point. The fact that there's this belief that water is free has been probably one of the biggest barriers. So what we keep focusing on is that everybody wants to be a part of something really good. And if we could just paint the picture of the mission and about how this is a chance to be innovative and a leader in whatever area the client is in, so that has proven to help. Sometimes making the story and getting them excited can help lead to more inclusion of great innovation.
My name is Audrey. In my case, I guess this topic of our panel, from individual practice to infrastructural change, is rather from research to infrastructural change. How can we bring it out of research into the real life? It's important to realize that there is not one solution for every case. In a project I was involved in the last year, which is actually led by the social science department, we developed together a theory of change for urine separation. And the aim of this is not only to formulate a vision, this is part of it, but it is also a working instrument to then find out how to get to this vision. First of all, you need to formulate an impact statement. Then you also need to know where you are now. Then you have a timeline, and you can define actors that are involved in the transition. And once you have those, you can define the milestones, which are here the squares, and then interventions that are needed to reach those milestones that you put in the timeline. And once you have a lot of information together, you try to define impact pathways. So here highlighted is one impact pathway that will lead to a paradigm shift, for example. So we elaborated the paradigm shift is something that is needed to reach the goal that we defined that we want to reach by 2030. And
I'm a wastewater engineer. I work for a medium-sized company here in the Northeast of the United States. I first became involved with the Rich Earth Institute, I think in 2011, what I see as one of the first obstacles to wide-scale acceptance of urine diversion, which is the general invisibility of wastewater infrastructure in general. I'm speaking primarily from the United States context. I want to draw a parallel with climate change. When you think about the history of climate change and public understanding of that issue, the first sort of step was unwilling scientists who stepped into the limelight and said, hey, we've got an issue here that we are trying to solve. Just as the climate scientists needed to do, I think we all need to be a little more vocal, and that may be uncomfortable. The second is just the scale from a funding perspective, some of the sunk costs in existing infrastructure. There has been significant dollars spent on wastewater infrastructure as it exists currently. The regulatory requirements are driven by what's written in the Clean Water Act as the limits of available technology. And so what that means is as the technology improves, the limits on pollution that a treatment plant is allowed to discharge into the receiving water is going to get ratcheted down and get tighter over time as the technology improves. And what that's set up is actually kind of, in some ways, a perverse incentive where over the last few decades, we've had large manufacturing companies develop technologies at increasing cost and increasing complexity. And that has driven the limits, the regulatory limits and the permit discharge licenses, the limits in those licenses down because the technology is now available, but it's become very expensive. Our goal really is sort of leading the curve here, and technological advances is to advance the technology to maturity or what was referred to as the technology readiness level, so that when there's infrastructure spending that is available, that we can be part of that funding. I think entry points into that are particularly environmentally sensitive areas. And then from that base, I think we expand as the useful life of the existing infrastructure that is in the ground expires. We'll have an opportunity to replace it with something better. What I think of as a provocative image, or what kind of drives me to thinking about where we can head, there's a need to decentralize our wastewater infrastructure. And just as with solar panels on roofs or wind turbines, every house could become its own energy production facility. I think with some technological advances, every house could also become a fertilizer production facility as well.